Hi, I'm Jon and I work for Sigma Connectivity. You're watching a film that's a collaboration between Scanfil, Nolato, DigiTab and Sigma Connectivity. I will talk to you about our joint capabilities to bring IoT products to the market. Sigma Connectivity is a global tech house. So our customers are other companies and organizations that are in need of digitalization. We help to identify, design and develop connectivity solutions, and we follow our customers on this journey all the way from idea to mass production. Our projects start with a concept phase. The customer comes to us with an idea. It could be anything from a basic idea on a post-it note to a fully defined product. We then start with a customized workshop based on this idea. Here we define what the problem is that we want to solve and what value we want to create for the customer. Once we know this, we can dig into what services are needed to realize this and how to enable it through technology. Together with the customer and our specialists, we then define the high-level requirements and document them in a product requirement brief. This is a very high-level document that describes what a product is and what it needs to do. For a simple device, it can be a thing that measures data, does something with the data, and then sends it somewhere. With the high-level requirements in place, we can then go into the definition phase of the project. And here we do several things in parallel. On one hand, we start with the project architecture. We define the low-level requirements and we estimate the entire project, for example. The design team starts to work on the industrial design and the user experience. And we can also do very early prototyping, both as concept sketches and 3D models and physical 3D prints. In our extensive labs, we have several different 3D print technologies. Liquid resin-based printing can print complex designs that combine several different materials in the same print. For example, you can combine plastics and rubber. Other printers can do materials that are closer to production-grade plastic, and that lets us investigate how the radios and antennas will behave in the end product. We also have fully equipped mechanical manufacturing labs, and these help us create pretty much anything that the designers can then dream up. After the concept phase, we move into the development phase. And a lot of things are going to happen at the same time here. The design team starts to do the DFM, design for manufacturing. And this is done in collaboration with the partner that will create the mechanical parts, Nolato in this example. And here the design is locked down and made sure that the parts can actually be manufactured. At the same time, we do electronic design and ECAD. This is done in collaboration with the EMS. This is the electronic manufacturing service, in this case Scanfil, who makes the PCBs. This is the partner that creates the electronics, the PCBs, the things that go inside of the product. We make sure that the design is efficient and within the partner's production capability, that it can be made. We also start to develop software. Everything we do here has embedded software as some kind of bottom layer. This is usually referred to as firmware, for example. This is what makes everything work and has all the different parts talking to each other within the PCB. There's also back-end development. That is things that happen in the cloud. Front-end development, that's what you as a user see when you use a product. It can be on the device, if it has a screen like a phone, or an application on your phone, an app, or something shown on a web page, for example. And for most products, verification and certification software is also required. This is software that puts the radios, for example, into specific modes for certification. It can be an external software that does automatic testing of a complex product. We also start industrialization in parallel with this. In the industrialization process, we have a tight collaboration with the EMS, Scanfil, And here we help setting up the production line. We design the physical test rigs that verify that each device you get passes verification. We also design and write the test cases for those rigs. We create flashing stations that puts all of the software on the device once it's made in the production line. By now, we also know enough of the design to start the sourcing. We start with something called a bill of materials, and this is just a long list of all the components that goes into a product. It includes a second and third source for critical components if they need to be changed in the future. The expected end of life for components, prices, availability, and so on. And we have sourcing experts that have worked with finding components for well over 20 years. They have connections with all of the component manufacturers, and they can usually get hold of things that are normally not available on the open market. Sourcing is of course done in close collaboration with the EMS, Scanfil, because they're the ones that are going to use the parts in the end. We make prototype batches in our own assembly labs. We have a dedicated team with pick-and-place capability for the smallest components that are currently in use. They can run small series in-house, and once we need more than, let's say, 10-20 devices, it usually makes sense to move that over to the manufacturer, Scanfil, for production. But we have set up entire production lines in-house for dedicated projects, if it's very time critical and very important for the customer that no information leaves the building for confidentiality, for example, super secret projects. This is of course not cheap, but it's well within our capabilities. Product development usually go through 3 builds before we have a finished product. The first build is called EVT, and this stands for Engineering, Validation and Testing. The EVT build fulfills all of the functional requirements of our product. It fulfills all of the functionality and all of the metrics that we have defined previously in the requirements. And if we want to change something, it should be done at this stage or earlier. Late changes to a project is time-consuming and expensive, so we want to make sure that we are happy with everything at this stage. Here we make use of our extensive labs. We can measure the antenna performance in the SATIMO chamber. So this chamber has complete radio silence and does not reflect any radio signals and lets us get a 3D model of the radio field from the product. We can use this to tune the radio to get a better performance. If you, for example, have a device that should be wall mounted, you don't want to send radio into the wall. So a spherical radio pattern is not very useful, it's wasteful. A half circle would be much more efficient. The same goes with everything you wear on your body or interact with, for example phones or wearables. You want to make sure that the radio field is optimized for the use case. We can also laser cut antennas in our labs if we want to test different physical designs. So our antenna engineers can create a theoretical antenna design, laser cut it in thin antenna grade copper, and measure the actual radio field in the antenna chambers within a matter of hours. And this lets us be highly efficient and design completely custom radio solutions for our customers. We can do the same when it comes to audio in our advanced audio labs. Here we can measure and tune completely custom audio solutions. For example, microphone arrays for a device with voice assistance that needs to work in a high noise environment, or devices with speakers that provide high-end audio experience for the user. Our Optolabs does similar work but focused on optics, both when it comes to screens and measuring the performance of different sources of screens in order to find the perfect screen solution for this customer. But we can also do it when it comes to cameras, for example AI-based image or video recognition. After the EVT build, the next build is called DVT, Design, Verification and Testing. So this build is run in a much more mature production line at the EMS, Scanfil, with mechanical parts from the mechanical manufacturer Nolato. And The DVT build fulfills, well, of course, all of the functional requirements from the EVT build. But it also fulfills all of the design requirements, the environmental requirements, and the certification requirements. On this build, we do a lot of mechanical and environmental verification. So we have test chambers that simulate extreme heat and extreme cold. We can do drop tests where we drop the product in very specific angles from a specific distance in front of high-speed cameras. And we can compare this to mechanical simulations that we did earlier in 3D. We have UV chamber that can simulate aging by exposing the device to a concentrated UV light. We test water pressure, we test rain, we test vibrations, corrosion, repeated mechanical wear, and so on. We also do pre-certification. We do all of the certification tests for all radios to make sure we will pass certification. Certification can be both expensive and time-consuming. And in order to make sure that we pass all the certification, we have some of the most advanced labs in US and Europe that's available on the open market. For example, we have worked with 5G for about 5 years now. We have full 5G capability, including millimeter wave chamber and all of the measuring equipment. Once we're through pre-certification, we initiate the final PVT build. This is production, validation, and testing. This is the build that comes off the actual production line. It's also a build that is verified in production on the verification equipment that we have built, and this is what goes into certification. So at this stage, most of our work is done. We are on standby, assisting the certification house with any questions that they might have, and we can also address any quality issues in production. We have an advanced analytics lab that can X-ray devices in 3 dimensions to make sure that everything is as it's expected, or do root cause analysis if something is not. Here we can, for example, see things like voids in the solder on a specific pad. We can also do more invasive investigation, for example, to see if the gold plating on a component has the expected thickness and so on. Once the certification is passed and the production line is up and running, our work here is done.